when I do, so today's 9/18/18, right? Okay, so the calculator, boy, these things are really good. They can do a lot, right? But if I want to put a graph, and I want to put it on the calculator, I got to make sure it has the right window. So if I go to my plane to my window, see the window I have on this calculator is not going to work at all. And I just happen to grab one randomly. This is a bad window. Meaning 90 to 120, we would never see this graph, right? Because the window on this thing is way up there, correct? So the first thing I'm going to do is make my window fit my graph. So I'm just going to go -10 to 10, right? -10, 10 on the x's, scales by ones. And then the y's will go -10 to 10 on the y's. And then I've got what we'd consider basically a standard basic graph, right? So I go to my y equals, clear that out, and I'll go my x squared, subtract 4. And we already kind of know what this looks like, right? And I'm going to go ahead and push graph. And there it is, right? Now we knew what this looks like, but I want to show you a new feature, okay? So let's go to 1, 2, 3, 4, 1, 2, 1, 2. And I'm just going to graph in the parabola. I mean, this one we know, right? Looks something like this. Now I want to show you a new feature. So the minimum. We already know the vertex is at 0, -4, right? Sometimes it's hard to figure out what the minimum is. The calculator can find the minimum for you. So watch. Everybody watching? We know it, okay? You guys agree? This is the minimum. This is it right here. See this blue button right here? Everybody look. Coop, watching? See this little blue button here? It says calculate. So let's go second, calculate. So I'm going to go second, calculate. And it has a minimum feature, okay? Want to do that again? Okay, I'll quit. So it's right there in blue. Second calc, down trace. And I'm going to go down to that minimum feature. So that's going to help me find the minimum of the point, okay? Now, some graphs, and we're not there yet, some graphs can look like this. So then there's a lot of different minimums, aren't there? So the calculator doesn't know. You have to tell it where to look. You have to tell it where to look. So if I push minimum, it's going to say first, give me a left bound. It wants you to tell it where to search. So I move my cursor over to the left-hand side of my minimum. It's blinking, 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 blinking. Now to push enter, it's going to lock it in. Once the right-hand side, so put it on the other side of my minimum, just somewhere, okay? It's blinking, blinking, blinking. If I push enter, it's locked in. Now, I'm telling my calculator to look somewhere in here for the minimum. So push enter again, and there it is, at -4, right? Now, this is weird because it gives us this strange number. That is 0. The calculator doesn't do math. It just looks for us. Look, look, look. It thinks it's at, you ready? Watch this. It thinks it's at 0.00002609, blah, 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 -4. But that is 0. That's for sure 0. In fact, we can prove it's 0, right? We can prove it's 0. The calculator can't do math. It searches for things. It thinks it's there when we know it's at 0. So when you see those weird numbers, you know that's 0, okay? So it's our minimum.
Wait, Mr. Davies, what's the number when I go like 2 plus 2 and then hit the enter button? Oh, that's good. That's a good one.
Nice. Okay.
Because I know that.
All right. Okay, let's do the next one. So sketch this graph, all right? Y equals, clear that out. I'm going to put in my x to the 3rd power, subtract 9x, okay? And to the power of, that's that button right there. If you want to go to the power of, right? You want to go to the power of, it's that button right there. So I've got x to the 3rd power, subtract 9. If I push graph, okay? If I push graph, I get that right there. Now, it looks like I need to see a little bit more of it. So I'm going to go a little higher on my window. Instead of y being up to 10, how about we go to what?
10.5.
12.
I like 12. No offense, I like 12 better. So if I go to my window, and I changed my Y max to 12, right? I see a little bit more.
All we need is 10.
And my Y min, how about we make that go down to maybe negative 12, and we'll see more of the graph. Does that make sense? Okay, and if I push graph, hey, then I can see the whole thing, right? So just change my window slightly so it looks something like this. Okay, so I'm just going to put a sketch in, looks something like this. Now, how about the min and the max? So let's do this whole process again. No, you can't have a chair right now. You just stand for a while. Okay, now, so if I want my min or max, again, I'm going to go to my calculate, right? Go to my calculate. So I go second, calculate. Let's do my max this time so we can find this one. Let's do my max. Am I going too fast? Okay, enter. And my max is the left bound, so I'm going to put my cursor all the way to the other side of that maximum. See how I did that? Okay, I put my cursor right over there. It's blinking, 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 blinking. I push enter, locks it in. Bring it all the way over the other side. It's blinking, blinking, blinking. Enter, locks it in. Guess. Okay, so where is it? It's at about...
Wait, how do you know when to hit enter?
I'll do it again, okay? Hit the enter when it says guess. When it says guess, okay? So I'm going to do then a negative 1.73 comma about a 10.4. And then, guys, go ahead and just put it on my desk. And then let's do the minimum. So if I wanted the minimum, okay, oh, let them in. And then, where's the worksheet for you guys?
I don't get like the minimum maximum thing yet, Dave.
All right, well, we'll try and go over that again.
Okay, so
Okay, I
how
need to
the
get
cursor
you guys
is
notes.
blinking, and then I go to the left.
Yeah.
How do you know when to stop going left?
As long as you're left of it, somewhere of it, right? And I'll do it again, anywhere left of it, right?
And then
Anywhere left from the maximum.
how do you know if you're on the same spot on the right of it?
And then
I'll do it
If
again,
you're on the
okay?
same spot on the right of it?
You know, we should just go for these guys. Oh, my goodness, thank you so much. Okay, Matt, give me one of these.
Yes.
yeah, it says guess question mark.
So, all right, let me do it again. So this time let's find the minimum, okay? So I go to my calculate, second,
Wait.
calculate. So, Mac, I'm hitting this,
It doesn't say guess, bro.
I want that right there, okay? So I'm at second, cal. I'll let you catch up, okay? We'll do this several times, all right? And so this time I want the minimum, right? I want that value, so I'm gonna go to minimum. Enter. Now, it says left bound. So if this is my minimum here, I want to go somewhere to the left of it. So I'm just going to go, see my cursor? So that's to the left of it. I could be here, that's still left of it here. I could be even up here. You just have to, even up here I could still be, but I like to get kind of close to it. So somewhere to the left of the point I'm looking for, okay? Enter. Now it says left bound, so I bring it right bound, so take it way over here, okay? Somewhere to the right of it. It doesn't matter, anywhere to the right of it, as long as it's to the right of the point you're looking for. Enter. Now it says guess. So you don't need to guess. If I were a good teacher, I'd say, well, let's see, I think it's right about there. What do you think? That's my guess. Right? We don't need to. Just say,
Wait, right about where? Like 10.4?
about there.
Shut up so we can tell what to do.
And there it is. So,
Wait, what did you just do?
well, that's not the right answer. Now I really got it messed up. Let's do it again. Second, calculate. I don't want to guess. Minimum. Left bound. Enter. Right bound. Enter. Enter.
Just hit enter again.
Yes, hit enter again.
Anywhere?
Yeah, as long as you're on the right, then the left. When it says guess, just push enter. When it says guess. I want you to guess, but we don't need to guess. So, my minimum's at, I'll do it again, 1.73, comma, negative 10.4. Okay, there's my minimum, okay? And we're going to do this, believe it or not, 3 or 4 more times because we're going to turn the paper and we're going to do it again, okay? Because I want you to get good at this, okay?
Wait,
yeah.
didn't I say that we only need 10.5?
Yeah, but mine's more accurate. Cody.
Wouldn't you only have to do the other one and then just know that the import on one's numbers?
Yes, absolutely. It is symmetrical, isn't it? Nice, exactly. Totally right. And we're going to see that in one of these others, okay? Turn the page, right? Okay, the x cubed. So same thing. We're going to go to our calculator. We're going to go ahead and put in y equals, clear that, x to the third power. Okay, got it? Okay, and graph, right? Now, this one doesn't have a max or min, does it? Doesn't have a max or min. So it just has what this kind of like cubic thing right here, and it bends right there. Goes up, okay? So that's neither a max nor a min. We'll call that an inflection point, okay?
That sounds good to me.
So an inflection point's really important to a business. Okay, I'll tell you why. Let's say that we have a business. Ben, you listening? See if we got a business, and all of a sudden right here our sales start to slow down. But I hire a young salesman, Ben Piers, because I hire him, my sales start to go up again. So in a business, the inflection point, as long as it's going up, is a good thing, right? Might even be investing money into a new building or whatever. But an inflection point is where a business changes and starts to gain again, okay? It's not a max, it's not a min, it's more like a bend is my inflection point, okay? All right, let's look at number 4. Number 4. Okay, let's put that in our calculator. I'll get rid of the smudge. Okay, so we're going to go to y equals, clear that out. We're going to go x to the 4th, subtract 3x squared, subtract 5, right? Okay, let's put that one in and see what it looks like. Go to graph.
That is a crazy graph.
Weird, isn't it? Okay, we're going to take what Cody said earlier, and we're only going to find one min because we'll know the other. Okay, so let's just make a real rough sketch of that. It doesn't have to be perfect because we're going to get those points down. Okay, so it looks something like this. Looks like a W, doesn't it? So I have 2 minimums, right? And I got a maximum, right? I got 2 minimums. But if we find this minimum, we should be able to get the other, right? Right, if we get this one to the left, we should be able to get the other one, right? Because it is symmetrical, right?
Calculate.
So let's go to, let's go to second, calculate. So we want this button here, let's calculate. Let's go to minimum, right? Let's go down to my minimum. Okay. My minimum is right there, so I'm on the left of it. So, okay, I'm at the left of that, right? I want this point here. I want the left of it's here, and then I'll go to the right of it. I'll go put it right maybe there. Okay. So it's blinking. I push enter, it locks it in. Bring it to the right, maybe right about there. So left and right of it, it's going to find it. Enter, enter. Okay. So what is it? So the minimum then is at.
Negative 1.224.
Yeah, negative 1.22 comma negative 7.25. But then down here, this point's got to be a positive 1.22, negative 7.25. So we've got both of them, right? Because it's symmetrical. Now the max value is right here. Let's let the calculator find the max. Am I going too fast or am I okay? So we'll do the max. Same thing with a second. Calculate our maximum. Enter. Left bound, maybe right about there. Okay, it's blinking, blinking, enter, locks it in. Okay, it's blinking, blinking, enter, okay. Guess. So an same thing, that is a 0. That is a 0, because it's exactly at 0, negative 5. And we can prove it. It's got to be 0, negative 5. Okay? Huh? Okay, let me do one more. Okay, let's do one more and I'll go slowly with you, okay? Right? Nikolai, let's do the last one, okay? And I'll go slowly, okay? Do you want to, okay, let's go y equals first, right? Clear that out. Let's do an x to the 5th. Subtract 3x to the 3rd, right? plus 2, right? Let's type that in. Nikolai, how I'm doing? I'm going to push graph, right? Okay. This one's pretty weird. So it looks to me as I have a, you watch Nikolai? I've got a max there. I've got a min there, and that looks like an inflection point, doesn't it? Looks like a bend. I've got a max, a min, and an inflection point. Ben. So,
Still on number 4.
well, can I move on to number 5 and I'll come back with you later? So my graph, I think, looks something like this. Okay, it's going to come up. I'm going to get a max. I'm going to do a little bendy here. It's going to go back down and back up. Okay, there we go. All right, now let's get the max and the mins first. Okay, Nikolai, that's a max, right? That's my max. So to get that, go through it slowly. Are you with me? I'll wait for you, okay? Because I want you to calculate, okay? So we're going to go to second calculate. You got it? Devin, you're going to need one of these, but...
Yeah, Devin, closed.
Okay, are you there? Nikolai? Let's go down to maximum. Okay? Down to maximum. Okay, you ready? Push enter. Okay, now,
So is
we need to...
maximum the one on the left?
Well, we need to know where to tell the calculator. Look, so it says left bound. So left of my maximum, I put a spot. I put a point left of my maximum.
Does it matter where?
Doesn't matter where, as long as you're left of it, okay? Push enter. So now I'm trying to tell the calculator where to look, right? This is right bound, okay? So right bound, I'm going to put my dot to the right of it, because what I need to do is tell the calculator where to look, okay? So I push enter. Now, I'm telling the calculator to look right in here. And it's going to be in there, isn't it, right? You don't have to push guess. It says guess, forget guess. Just push enter, okay? Push enter, and it's going to tell you. So my maximum is at a negative 1.34, comma, about a 4.9. Okay. How is that, Nikolai? Better? So let's do the minimum, okay? And I'll wait for you. Let's do the minimum, okay? Max is helping. Okay, so to do the minimum, my minimum is that point right there, correct? So we're going to go to second calculate minimum, okay? Nikolai, how am I doing?
Good, just keep.
Okay, tell me when you're with me. You good? Enter. Now you have to tell it where the minimum is. So it needs a left bound. So left of my minimum would be maybe right around here, right? So I'm left of it. See, it's blinking. So I'm right here. Push enter. You're just telling where the calculator to look. Enter. And then the right bound, I'll put it the right hand side of that. Somewhere to the right hand side. Somewhere to the right hand side. So I'm telling the calculator where to look. Okay. Enter. Guess. So now you have a 1.34.
What? 3.4.
I have a 1.34 and a negative about 0.9. Okay. Okay. Now
Is it supposed to be all that number?
let's do the easy part. Okay. So then what I'm going to talk to you about next is the easy stuff. Okay. Right. So you ready? Let's turn the page back. Okay. So this is an x squared. What do you notice about the difference between an x squared and x cubed? This is an x squared. This is an x cubed. So they're all curvy, aren't they? They're all curvy. These are called polynomial functions. They're curvy, okay? Here's an x cubed. Here's another x cubed. This one doesn't have as much curve because it doesn't have any extra terms, right? So if we put extra terms in there, it starts to curve it more, okay? Here's an x to the fourth. Looks like a W, doesn't it? But it's curvy. Here's an x to the fifth. Look at all those curves at x fifth. So the more terms you add into it, the more curvy it gets. Now, check it out. X squared is an even exponent. If it goes up at the end, it will finish going up that way, okay? X to the cube, though, it's an odd one. It goes off to positive infinity, and then at the end it goes down to negative infinity. See that? X cube's got to go up like that. But then if I take a look at x to the fourth, what do you notice about x to the fourth? End behavior. It goes off infinity, off to infinity, right? How about x to the fifth? So if it's even, the graph will always end either both up, even, or both down. Odd is always going to end like this. Up, up, or vice versa. Does that make sense? Even's always going to finish the same way. Odd's always going to finish one up, one down. Always, okay? And the bigger the degree, the more curve it has, all right? Now, end behavior is kind of weird, okay? So, end behavior, real quick. Okay, we'll look at that later, okay? Right now, let me keep going, okay? End behavior. So, let me ask you an easy question. Where's this graph? See where I'm going? Where's this graph going to? It's going up. It's going up, right? How far up does it go?
Always.
Always. In fact, it goes to infinity, right?
And beyond.
So its end behavior, it goes to infinity. How about this one? Where's this one going to? If you can sit quietly, yes. Where's this one going to?
Negative.
It goes to negative infinity, okay? Does that make sense for end behavior? Okay. All right. How about this one? Where's this one going to? Positive infinity. And then where's it going to end over here?
Infinity.
Also infinity, right? So here's what the book's going to show you. They're going to say as x approaches infinity, as the x values get bigger and bigger and bigger, then the y approaches infinity. The book's going to do this, okay? The book's going to show as x goes to negative infinity, so x is going to negative and negative, y is going to go to positive infinity. I'm going to look at this some more because this is the hard stuff. But we're going to talk about this more, okay? All right, so I'm going to stop recording, take a break, grab your journals, okay? Stop recording. We'll see if this even worked.